Hello everyone and welcome to another video on Work Energy Theorem for grade 12, okay? Here we're looking at work example 5 like I told you, which is actually the second method or second approach, okay? And of the same question. Alright, all we're doing here is just you calculating the net force here instead of the net work. Using the net force to calculate the net work done on the object, in this case a car. Now, again, let's refresh our memory about the question. The same car is now accelerating forward, but friction is working against the motion of the car. A force of 300 newtons is applied forward on the car while it is traveling 20 meters forward. A frictional force of 100 newtons acts to oppose the motion. Calculate the net work done on the car. Solution. Step 1. First and foremost, as always, just like in the previous video and all the other videos which I have tutored for you, we always analyze the question and state the information that has been so generously and kindly provided to us. Now, this is the same information that was provided to us in the previous worked example. In approach 1, it's the exact same information. Force applied, 300 newtons. The force of friction, 100 newtons. Now, the force applied is going forward and the friction is going backwards. The distance is moved, delta x, 20 newtons, and the applied force is 300 newtons, and the force of friction is 100 newtons, are in the same plane as the distance moved. Woo! Therefore, we can add the vectors. Now, as vectors require direction, we will say that forward is positive, and therefore backward is negative. Note, the force of friction is acting 180 degrees, i.e. backwards, and so is acting in the opposite vector direction, i.e. negative. Okay, so we're taking forward as positive, okay, and then that's normally what most people do, okay? Forward is positive. Again, these quantities are in the correct units, so no unit conversions are required here. Alright, happy days so far. Let's have a look at step 2. Now, what do we do with step 2? Now, we first analyze the question and what is being asked. Now, they ask us to find the net work done on the car. And using approach 2, we know that the net work done, W net, is equal to the F net, or the net force, delta x cos theta. Step 3, we now calculate the net force acting on the car, and we convert it into the net work. Now pay attention over here, we draw a force diagram. They have actually drawn a free body diagram there for you, okay, but they have still denoted the forces. We know there's no work done by the normal and the gravitational force, so those can be omitted. Alright, but there's work done by the force of friction and by the force applied. They tell us there to let forwards to the left in the picture be positive. Okay, we know that the motion of the car is in the horizontal direction, so we can neglect the force due to gravity, Fg, and the normal force, N, of course, as I've just said. Note, if the car were on a slope, we would need to calculate the component of gravity parallel to the slope, which is Fg parallel. Okay? Alright, now working out the net force there, we know is the force applied plus the force of friction. Alright, we know that the force applied is positive 300 newtons plus negative 100 newtons. Force of friction is negative. That yields us an answer of 200 newtons forwards. That is the net force. Okay. Now, the net force is pointing in the same direction as the displacement. Therefore, the angle between the force and displacement, theta, is 0 degrees. And we know what cos 0 is. Cos 0 is 1, so our W net formula equals to F net delta x cos theta. That's 200 times 20 times cos of 0, which is 1, so just 200 times 20, and that gives us a final answer of 4,000 joules. the exact same answer we got in the previous video. Okay, by using the approach 1. Now, approach 2 seemed like, in this question, to save time. Alright, and it looks like it saved a lot of time. There was less calculations. Okay, but it is all up to the person answering the question whether they would like to choose method 1 or method 2. Sometimes only one method will work out. Alright, sometimes, but it is up to you to decide which method you would like to use. Okay, I am in favor of method 1 because simply it's just my favorite. It's just what I enjoy. I enjoy method 1. Okay, right, moving on. Let's have a look at an example. All right, let's look what we have here. Now, example, a boy drives his 3-kilogram remote-controlled car up a 4-meter-long plane, which is inclined at 25 degrees, to the horizontal. The car's motor exerts an average forward force of 40 newtons, and the car experiences a frictional force of 50 newtons as it moves up the incline. Calculate the net work done on the car. Well, let's go do that, shall we? All right. So, if we go and do that, if we have a look at the drawing, let's see if we can redraw the drawing again. Let's draw it a little further down here. All right, there we go. Okay. All right. Oops, no, let's try it nicer. There we go. All right, there was our 25 degrees. Okay, so let's draw our little car here. All right. All right, cool. There's our car. There's our little Mercedes. Okay, let's call it Mercedes. Just for fun. All right. So in this question, the question states the car moves this way. Okay, and there's a frictional force going this way. And we know that on the object, all right, there is a because it's on an incline, we know that there's a force here that exerts a 40 newtons. There's a 15 newton force here, and also we know that because it's on an incline, there is a FG parallel component here. All right, FG parallel component, which is mg sine of sine of theta. Okay, we know the FG parallel component there. It was 3 kilograms. All right, times 9,8 times sine 25. All right, so that will be, if we punch it in our calculator, all right, we will get an answer of 12. Oh, get my pen right. There we go. 12, comma. Let's see there, 42. Okay, to 2 decimal places, 12,42 newtons. All right, perfect. Now we got that. All right, so now we know the approach to this question. Okay, to this example. I'm going to write it out here. Here we go. What do we have? We had the mass was equal to 3 kilograms. Okay, they told us that the force applied, we can say, was 40 newtons. All right, I'll go back to the question to make sure in a little bit. We know that the force of friction was equal to 15 newtons. All right, and we worked out that the FG parallel component, parallel to the incline, was 12,42 newtons. All right, and we know that the displacement, right, if we go back to the question, well, I have to go back now. The displacement is 4 meters. The displacement was 4 meters. Okay, well, let's go back here. 4 meters. There we go. Now, if we use approach 1, we know that we need to calculate the work done by all of these components. So what I'm going to do now is I'm just going to erase the diagram quickly. All right, just going to erase the diagram. Just erase it nicely, okay, because you already know what's going on. Okay, cool. And now that we already know what's going on here, so we need to calculate the work of the force applied and the work of the friction, and we calculate the work of the parallel component done by the incline. Now it might make sense just to use the net force component here, so it might make sense just to use the FG or the F net approach. So let's actually just go with approach 2, because it's the easiest way to do this one, approach 2, because there's 3 things we have to work out here. So let's actually just not do that. Let's calculate the net force rather. So the net force, okay, right, we know that that is the force applied plus friction plus FG parallel, because that's parallel to the slope. Okay, so if something is parallel to the slope, it means it's going in the same direction of motion. Okay, so we know that's positive, and that is negative. Okay, we take it upwards as positive because that's the way the car is moving. The car is moving upwards. Okay, so we know the force applied was 40 newtons, plus the force of friction was 15 newtons in opposite direction, so backwards, so we're going to make that negative. Alright, plus 12,42. Alright, so when we do that, what we do is we take 40, right, plus negative 15, so minus 15. Alright, plus, alright, we get an answer of 37,42. Alright, newtons as our net force. Okay, I rounded it up to 2 decimal places. Alright, then we can put it in our formula. W net is equal to F net delta x cos of theta. Alright, what we can do here is we can say the net force is 37,42 multiplied by 4 meters multiplied, because the applied force is going in the same direction of motion over here. Okay, let's just check that. The car motor exerts an average force. The car experiences a frictional force as it moves up the incline. Alright, and it moves up the incline of 4 meters long. Alright, so that's the same. So therefore it's cos of 0, which is 1. Alright, if we take our answer, I multiply it by 4, you get an answer that therefore the net work or overall work done on the object is equal to 149, 70 joules. Or you could just write 1,49,7 joules. Okay, because the 0 doesn't really matter. Okay, and there you go. That's our answer. Well done. Alright, and that's the network done by the car up the incline. Okay, that's the network done on by all the forces acting on the car as it goes up a 4 meter long incline plane.